Başlattım. Madem öyle bu dersi ben bakayım bir. Karantinadayız hocam. Ne alaka anlamadım. Hayırdır? Pozitif miyiz? Neyse. Geçen haftaki konudan hızlıca bir bahsedeyim. Shift'ler vardı arkadaşlar. Kaydırmalar. Sola kaydırma, aritmetik sola kaydırma, sağa kaydırma, aritmetik sağa kaydırma şeklinde. Shift left ile shift aritmetik left birbirinin aynısıydı. Hatta Machine Language'e çevrilmiş halinde bile aynı gösteriliyordu. Shift right ile Shift Arithmetic Right birbirinden farklıydı hatırlarsanız. Soldan birisinde 0 girerken diğerinde Most Significant Bit geri giriyordu. Çünkü negatifse negatifliğini korumak için, pozitifse pozitifliğini korumak için, sign değerlerini korumak için. 4 tane örneğimiz vardı. Üçünü yapmıştık. Dördüncüsünü ödev vermiştik. Ödevimiz de şuydu. Bir değer varmış 1000H'ta. Bu 1000H'taki değerin nibble'larını, yani burada bir 8 bitlik değer varmış. Zaten 1000H 8 bitlik. Bu adresten başlayan 8 bit dememiş ama 8 bit olduğunu anlayabiliriz. Nibble'ları dedik mi mesela AB'nin, şöyle örnek verelim, yine örnek vereyim. ABH olsun 1000H'ta. H adresinde ABH olsun. Bunun nibble'ları nedir o? B. Nibble'ları. Hexadesimal tabii ki. Bit olması lazım. CL ve CH 8'er bit. Programın bizden istediği bu. 1000H adresinde bu var. CX'in içerisine nibble'larını da koyacaksınız diyor. Soru bu. Ben direkt cevabını açacağım size çünkü çok basit. Cevap da bu. Direkt emülatöre yapıştıralım. 1000H'ta bir değerimiz olsun diyor. Hatta AB aynı örneği vermişiz. AB'yi CH'a alıyoruz. Direkt emulate ederek anlatacağım. CH'a bakın. CH burası. CH'a alıyoruz. Şimdi bizden istediği CH'da A, CL'de B olması. Bunun için CX'i komple 16 bitlik CX'i 4 bit sağa kaydırıyoruz. 4 bit dediğimiz bir karakter. Hexadesimalde bir karakter olur. Kaydırıyoruz 4 kere. Kaydırdık. Ne oldu? CH istediğimiz gibi oldu. A yazıyor. Fakat CL B0 oldu. Bizse 0B istiyoruz. Yani CL'nin içinde B olmasını istiyoruz. 0B. O yüzden CL'yi de 4 kere sağa kaydırdık mı nibble'lar CH ve CL içerisinde olmuş oluyor. Soru bu kadardı arkadaşlar. Şöyle şunları kapatalım. Bunu indirelim. Evet, bu geçen haftadaydık. Evet, aramıza bir kişi katılmış. Enver, hoş gelmiş. Haklısın Ahmet. Şimdi, let me switch into English. Today's topics are rotates. Rotate left, rotate through carry left, rotate right, rotate through carry right. 4 instructions, 4 of them is different. This time there is no same instruction. Let's start with rotate left. The visualization in here is pretty explanatory. Let me minimize this thing. Rotate left. This is our register or memory or whatever it is. Let's say AX. No, let's say AL. Okay. How many bits is AL? It is 8 bit. There are 8 bits in this register. Rotate left is copying the most significant bit into carry flag and also copying that most significant bit into least significant bits, and all of these values shifted to left 1 bit. Okay, rotate through carry left is different. This is also AL. Let's say AL. The most significant bit will be copied into carry flag. The carry flag will be copied into least significant bit. This time, carry flag is in the calculations. So this is 1 bit. This is 8 bit. So this is rotate through carry left instruction is 9 bit. Rotate left for now. If I choose AX, for example, it becomes 16, so it becomes 17 bit AX. Let me zoom again. Whatever you choose here, +1 is rotating. The above is whatever you choose. There is no +1 because the most significant bit automatically dive into from least significant part. Okay. Rotate right and rotate through carry right is also same, but this time rotation is through right. The least significant bit this time, the least significant bit this time will be goes off into carry flag, and also this same least significant bit goes into the most significant bit. This is rotation, rotate right, okay? But if you rotate through carry, you have to pass through carry. So that's why the least significant bit will be goes off to carry flag, and the carry flag will be going to most significant bit. Like the same, but this time right rotate. This is left rotate. Okay, whenever we learn a new instruction, we open the help, go to instruction set, and open the new command. For example, rotate left. Okay, this is rotate left. The parameters are here. Let's see what are the parameters. It can rotate memory immediate times or rotate register immediate times. If you don't want to use immediate, you can also use only CL. You can't use CHAL or any other variable, just CL. But generally we use register immediate rotation. For example, let's put some binary value. Okay, this is 0, this is 8412B. Oh, A. This is A. Yeah, A. I'm going to rotate left AX. How many times? I'm going to rotate it like 4 times. Okay, let's emulate this one. Somebody write to me. Yep. Okay, we are rotating. I'm going to open the AX, and please carefully look at the AX. In here, AX is now filled with A0, actually only AL. So we are going to shift, we are going to rotate complete AX, rotate 16-bit. Not through carry, just a random normal rotate. Okay, I'm opening flex by the way. We can also look at the carry flag. Okay, a single rotate will jump 1 to AH. Another one, another one, another one. Okay, so the A value, which was in AL, now in AH, because we rotate 4 characters 4-bit is 1 character in hexadecimal, so a character rotated through AH. Okay, let's change this. L. This time not whole AX, but only AL. We put A0, and I'm going to rotate 4 times. 1, 2, 3, 4. Okay, it was A0. Now it becomes 0A because the first nibble rotated and entered into the least significant bit, and the result is 0A. By the way, let's open the flags and see the carry flag. Please look at the carry flag. The most significant bit is 1. When we rotate it, it will dive into carry flag and also least significant bit. So please look at the carry flag. It is 1. This is the least significant bit, and the one in here are same. Another rotate, carry flag is 0 because the most significant bit was 0. Carry flag is 1, carry flag is 0, and the program is finished. This way. This is rotate left. But if we change this into rotate through carry left and rotate 4 times, what will happen? Let's copy this value. Text editor. Okay. What will going to happen? Let's emulate carry flag also. Carry flag is now 0. This is our value. I want to rotate through carry flag. I want to open the PDF, by the way. Let me open it here. Okay, we want to emulate this one. Okay, the most significant bits will dive into carry flag, and the other parts will be here, and the carry flag will be in here. Another rotation. What will going to happen? The most significant bit will be in carry flag. The rest of it is here, and the least significant carry flag will be copied into least significant bit. This is how rotate through carry left works. Okay, let's emulate. Open AL, open flex. We have A0 in AL. Rotate 1. It dive into carry flag, but didn't enter from least significant bit. Be careful. I'm going back and forth. It goes off to carry flag, but not entering from the least significant bit. And next one, and next one. So rotating completed. We rotated 4 times, but the result is not A. It was A when we rotate only left, but this time we rotate through carry flag. That's why we need to rotate it 5 times in order to get the same result back with the ROL, rotate left. Okay, 5 rotate, and the result is, as you can see, A. But we rotated 5 times. Okay, that's it. This week's topics is this. I'm diving into examples. I'm going to cover these 2, 1, and the third one will be your homework. Any question, by the way? Is there any question about rotations? Rotate left, rotate through, carry left. Okay, there's no question. First example, write a program that reads a word from 300 memory address and count the ones in this value, and write this count into dx. Okay, we have a value in 300h address. This address, let a word value. We need to read a word from starting from 300. So that's why we need to use word ptr. Word. Let's use F0 hexadecimal. This is 16-bit word value. Put it into 300 and 301. I'm going to get that value into AX by this. I don't have to use word ptr in here because AX is already word. It understands and put word ptr in here, but anyway, I write it down. Okay, we have a value in AX now. F0 is actually 4 1 from here, 4 1 from here. There are 8 ones in here. Let me write it like this. This is F0. Okay, the question wants us to count these ones by using rotation. How we are going to do that? Any idea? Any idea, guys? With rotate RCL. Okay. Ahmet says we need to use RCL. Okay, let's use RCL. How we are going to count the ones with RCL? RCL AX1. So what? I only know that I have a word value. Word means 16-bit. So I know that this memory or register has maximum 16 bits. So I need to do a loop. This loop should run CX times. For this example, it is 16. And at every loop, it will rotate left, but it does not rotate through carry. Oops. It rotate left, because if I use RCL, I need to clear the carry flag first, then run this loop 17 times. We will do that also. Anyway, okay, we rotate it 1 times. So what will happen? The most significant bit will be dropped into carry flag and also the least significant bit. So I need to check if the carry flag is 0 or 1. I have a jump carry flag. If the carry flag is 1, let's use the opposite band. Opposite jump not carry. Jump not carry to increase. I don't know where increase. Okay, increase that. After rotation, if carry flag is not set, it will jump not set, not increase. So within here, the question wants us to store the result into dx, I'm going to increment dx by 1. That unconditional jump to end. End is here. Okay, let's check. I just made it up. This is our loop. This will run 16 times. We rotate left by 1. If the carry flag is not set, it will jump into not increase. If set, it will not jump and increase dx and jump to end. So this is our first demo. Let's improve this program and let's check if it's doing correctly or not. After the program run, yes, the ones call number is correct. So this is correct, but there are some meaningless jumps. For example, jump not carry. If not, it will jump. Opposite version. Let's use the opposite version. Increase. Increase should be here. Not jump to end. This is an opposite version. dx is 8. This is also correct. But the more useful one, how can I do that? If carry flag is 1, increment dx. If not, end. Okay. To end gerekli because carry flag varsa buraya atlıyor ya. Carry flag yoksa buraya geliyor. Ve burada atlayıp bitirmesi lazım. Bunu yapmazsam tüm koşullarda bu çalışır. Carry olsa da çalışır, olmasa da çalışır. Bu biraz çirkin oldu. Ben şöyle bir cevap öneriyorum. Bizim add with carry'miz vardı hatırlarsanız. Carry'i ne olursa olsun toplama işlemine ekleyen. Binary işlem yaptığımız için carry ya 0 ya 1. We are working with binary calculations, so adding carry is only 0 or 1. So adding carry into dx with 0, this operation is actually dx plus 0 plus carry flag will be copied into dx. So 0 is unnecessary, so it just adds the carry flag into dx. So there is no need to check. Just increase the count is 8. Okay. Any other idea? There may be some better way to check how many times. At least 16 run is important. I don't think there is another way. Okay. Anyway, question, then write count to days. Okay. Okay, second example. Write a program that rotates the word stored at 300 memory address to left. The same memory location, same rotation left rotation. This is also, no, we use left rotation here, but we can also use, by the way, right rotation. There's no difference. It will also calculate 8 because, remember, left rotation dive into carry flag, right rotation dive into carry flag. Both of them dive into carry flag. But this time, question state that we need to use left until it will be negative. Okay, we have a signed value at 300 memory address, and we are rotating it to left until the value will be negative. And we need a rotation count. How many rotation makes this 300 memory address negative? Okay, let's change the value into something A0, B0. So this is A, this is B. A0, B0, A0, B0 is already negative. I need positive value. Or 0, 5, 6, 7. Or 4, 5, 6, 7. Just an example, I don't know what it is. 4, 5, 6, 7. It's a bad example, sorry. Let's change it into 1, 5, 6, 7. Okay. Okay, this is our value. AX completely. The value is 1567 in hexadecimal. In decimal, it is 5479. Okay, I'm going to rotate left. Question 1 has to rotate left. AX sometime. I don't know how many times, let's say 10. And see when the AX become negative. We are looking at here, the signed value here. Can I zoom in here? I can zoom, but I can't click. Okay. Anyway. Okay, we have the value 1567 in AX. The value is signed and positive. We rotate left 1 and the value becomes 10,900 blah blah. Rotate another, the value becomes 21,000. Rotate another, it becomes minus. As you can see, after 1, 2, 3 rotation, after 3 rotation, the value becomes negative. How can a signed value become negative by rotation? Why the value become negative? Any idea? The value was here. After 3 rotation, it becomes negative. Current value is AB38. Any idea? Yes, Ahmed, thanks. The most significant bit becomes 1, and in signed values, the most significant bit is sign bit. If sign bit is 1, the value is negative. If sign bit is 0, value is positive. in our first example, our value is 1567. The most significant bit is here. It is 0. So the signed version of this number is positive. But after 3 rotation, most significant bit becomes 1. And 1 means minus. Minus means negative. Okay. So we need to check the most significant bit. Write a program that rotates the word on left until it becomes negative and save the rotation count into CX. If the value is bigger than, the question has 2 parts. The first part, try to find the rotation count until it becomes negative. The second part, check the result negative value of this rotation with A100H and compare them, which one is bigger. For example, if the result is bigger than 100, it says write AA. If not, write B. This is second part. Okay, now how can we understand the most significant bit is 1? Any idea? How can we check if the most significant bit is 1 or not? Any idea? Please remember the previous weeks, we have a test function. Test function tests 2 numbers. Test operation actually just AND operation. Let's say the value in BX binary. This is 16-bit value in BX. And when I AND this value with AX, please remember, it will only generate, AND operation only generates 1 when both of them is 1. So when AX first bit, the sign bit is 1, this will become 1s. At other cases, it will always become 0. So when I test these 2 numbers and check with 0 flag, if the result is 0, it means it is positive. If not, it is negative. That's why I need to use jump not 0, which means negative. Use negative in here. If it's negative, it just ends. If it's not negative, we need to rotate left 1 more times. And this operation should be done in loop again. Okay, how many times at max? How many times do I have to rotate in order to find a negative value of a number? Our value is word. A word is 16-bit. That's why we can use CX, and this will run 16 times. Within the 16 time, whenever a negative happens, it will exit out from the loop. With unconditionally. Okay, let's check if there is any error in here. Open the AL. Open the flex. Okay, we have 1, 5, 6, 7. The value is in AX. We are going to AND this value with BX. Within this loop, test operation is done. Please look at the zero flag. Zero flag is 1, which means not jump. Rotate left. Oh, it will end like this. So this is wrong. We need to use jump 0 positive. If it is positive, we need to rotate. If it is negative, we need to jump to exit. Okay. Open here, flex. Test, zero flag is set. It will jump, rotate, loop will start from beginning. Test, jump, rotate, test, jump, rotate. Now, the most significant bit is 1. It will test, but zero flag will become 0. As you can see, zero flag is 0. It will not jump and go to second line here, and that line will exit out from the loop. Okay. We have the value now, the negative value, which is minus 21,704. Okay, in 16-bit hexadecimal, what is 100? It is minus the value that gives us in question. This is the value we have in our example. Okay, my question is simple. Which one is bigger? Which line is bigger? The first line or the third line? Which number is bigger? Okay, guys, I want answers. Please. Which number is bigger? Minus 24,000 or minus 21,000? Simple mathematics. 6th grade question. Oh, come on. Okay, as we already know, minus 21 is bigger than minus 24. Yep, that's why our number is bigger than the given number. So if the last value is bigger than our bigger than 100, then write AA. It will write AA into 100,000 H address. Okay, after this exit, we need to check. How can we check if two numbers is bigger or greater than other? We need to compare. Remember, compare operation is subtracting from operand 1 from operand 2. So we have the AX value. We need to check this value with this value. After this compare operation, we need to use a jump, a proper jump. A jump that looks at the, let me open the help. A jump that looks at two signed values. Okay, jump above or jump greater. Which one I'm going to use? How can we understand? Jump above is, as you can see, used with unsigned values. Jump greater is used with signed values. As long as our values are signed values, jump greater is our jump. So I'm going to use jump greater. So here, this is not greater part. Greater part, okay, it will jump into greater. If it is greater, it will write 1000H to AH. If it is not, let me copy this line, it will write BB. Did I write correctly? Then write AA, not write BB. Yep. After not greater, we need to jump to end. And this here. Okay. Let's run this code and look at the 1000 position. It's writes AA because 21,000 minus 21,000 is greater than minus 24,000. Okay, if we use jump above, it will calculate wrongly. We can't be sure about the calculations, so be careful about using jumps if the operation is signed operation. Okay, this is the second question. We have already covered it. By the way, we didn't count the rotation count. It say you should put this rotation count into CX. Let's put this rotation count into CX. How can we put every rotation? Oh, we have CX. We use CX. How can we unuse this CX? Rotation count into CX. We can use dx and copy the value after, but that is ugly. Okay, let's not use test. We can do better by loop. I'm deleting completely here to exit here. Okay, I'm going to use rotate in order to find the most significant bit. I'm going to use rotate left. Endless loop. Within this endless loop, I'm going to rotate left. At first, I need to check if. Okay, no, I need to rotate first. Rotate AX by 1. After this one rotation, check carry flag, jump carry. Oh, I can use jump not carry. Döngü. This way it will rotate. Within this rotation, I'm going to increment CX. If carry, it will exit out. Yeah. Let me emulate this one. Okay, we have a value. Value is this. Open the flags. Rotate left. It doesn't have a carry. Increment CX. Rotate left. It doesn't have a carry. Rotate left. It doesn't have a carry. CX is now 3. Rotate another left, and the carry flag is 1. But our value is already negative. We rotate one more time. Unnecessary rotation. Okay. So this is end. It is correct. After this loop, we need to rotate right 1 times and decrease CX 1 times. Okay, that's it. We now have rotated AX and CX. We need to rotate 3 times in order AX to become negative value. It is in CX. Now the question is more correct. Okay. Any question? This is my answer. I will publish the answers, but it may be different than this. We get rid of this BX. We are not testing anymore. So you are lucky, guys. Okay, the last example. Write a program that rotates DX, BX, AX register combination to left for 4 times. Later, write results to memory address starting from 5000 H. Okay, let me explain your homework. You have a value in DX and value in BX and value in AX. Let's say these values are A, B, C, D, H. I'm not going to use hexadecimal in here. Hey, H in here. E, F, 1, 2 in BX, 3, 4, 5, 6 in AX. A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. These are the values written into DX, 0, A, B, C, D, BX, 0, E, X, 3, 4, 5, 6. This is our 3 value. The question wants us to rotate, take this 48-bit, 16, 16, 16, 48-bit register as a whole and rotate this all by 4 times. 4 times means 1 character. So after rotation, DX should become B, C, D, E, and BX become F, 1, 2, 3, AX become 4, 5, 6, A. After 4 rotation. What just happened? The most significant bit will we dive into the least significant bit. But within this BX to DX calculations, oh sorry, it should be like this. Rotation is like this. It will be here. Yep. The rotation you should do is this. You should rotate DX, BX, AX, or AX, BX, DX. I don't know the order. I don't know the rotation count. You should only rotate 4 times, and the result should be like this. Okay. Oops, none of Ahmet asked a question. Let me turn this back into here. Okay. Your question said that not greater'a nerede girecek? Not greater'a nerede girecek? Greater değilse girecek. Great değilse atlamayacak. Buraya girecek. Yani rotation'ları sonucunda elde ettiğimiz sayı bu sayıdan büyük değilse bu olacak. Not greater olduğu zaman girecek. Tamam. Evet, başka sorusu olan var mı arkadaşlar? Is there any other question about anything? The third example will be your homework. Try to solve it on your own or with your friends, but know the answers. I'm going to publish the answer. I don't know if the answer is correct or not, but I already gave the result to you. You can check the result on your own if it is correct or not. So that's it. I'm stopping this recording here.